So stoichiometry is the method of calculating various quantities from a balanced chemical reaction. So stoichiometry is this process of calculating. All right, so when you look at a balanced equation, there's a lot of pieces of information that you can draw from it. So if we were looking at this equation in terms of number of moles, the coefficients represent your moles. So we could explain this equation by saying that we would need 2 moles of H2S for every 3 moles of oxygen, and that would allow us to produce 2 moles of SO2 and 2 moles of water. So those coefficients represent the number of moles. For molecules, we know that 1 mole equals 6.02 times 10 to the 23rd particles. So we could take each number of mole times Avogadro's number, but if we reduced that to a much simpler way, you could also say from the balanced equation that 2 molecules of H2S react with 3 molecules of O2 to produce 2 molecules of SO2 and 2 molecules of water. So the coefficients could represent either moles or molecules, because molecules you would just simplify to end up with the same ratio. All right, in terms of grams, grams are a little different because grams is dependent on the molar mass of each element. So if we found the molar mass of H2S, you would take 2 times the mass of hydrogen from the periodic table, plus the mass of sulfur, which is 32.07. So if we added those together, you end up with 34.09. So that would be how many grams are in 1 mole of H2S. The balanced equation tells us that we have 2 moles. So we would take this value times 2, and you would end up with, oops, I'm going to switch colors here, 68.18 grams would be 2 moles, would be equal to 2 moles of H2S. If we looked at oxygen, we have 2 atoms of oxygen. So we would take 2 times the mass of oxygen, which would give us 32.00 grams. That's grams per mole. The balanced equation tells us we need 3 moles of that substance. I'm going to switch colors so I can keep it consistent. So 3 times 32 would be a total of 96.00 grams. So we would do the same for SO2. Sulfur has a mass of 32.07, plus we have 2 oxygen atoms. So that gives us 64.07 grams per mole. The balanced equation tells us we have 2 moles, so we have to take this number times 2. So we end up with 128.14. All right, and finally, H2O, we would have 2 times the mass of hydrogen plus the mass of oxygen. So 1 mole of water is 18.02 grams per mole. The balanced equation tells us we have 2 moles. So we would have to take this number times 2. Whoops, I forgot to switch colors. So then our total would be 36.04 grams would be equal to 2 moles of H2O. Okay, so here is one more thing to remember. We know that law of conservation of mass says that the mass that goes into a reaction is equal to the mass that comes out of the reaction. So if we add our reactants together, we end up with 164.18 grams of mass going into the reaction. And if we do the same with our products, we end up with 164.18 grams coming out of the reaction. So the mass going in between all of your reactants has to equal the mass coming out. So keep that in mind when you're comparing the mass of the substances. All right, so here's how we start with the stoichiometry. The first step is we use the mole ratio. So the mole ratio is a conversion factor from the coefficients of a balanced chemical reaction in terms of moles. So go ahead and pause the video to make sure that you get all that written down, and then we'll go through the example. All right, so from the balanced equation shown below, we know that 1 mole of N2 will react with 3 moles of H2 to produce 2 moles of NH3. The question off to the side for the mole ratio only asks about N2 and H2. So those are the only two elements that we're comparing. Moles of N2, we know for every 1 mole of N2, we would need 3 moles of H2. So the coefficient is where you get that information for your mole ratio. All right, so let's try this in an actual calculation. So you really have to be careful about what chemicals the question is asking for. Question 1 says, what's the mole ratio between C8H18 and O2? So the problem is only asking about these two chemicals, so when we only care about those two chemicals. So we know the ratio from our balanced equation is 2 to 25. For every 2 moles of C8H18, we would need 25 moles of O2. All right, question 2 says if you reacted 4 moles of C8H18, how many moles of O2 would you need? So again, we're comparing these two substances. The recipe says for every 2 moles of C2H18, we would need 25 moles of of oxygen. So if we double the amount of that first ingredient that we need, we would have to double the amount of oxygen that we would need. So this question would require 50 moles of O2. All right, question number 3 says if you use 75 moles of O2, so now we're comparing O2, we want to know how many moles of CO2 would be produced. So now this is the only ratio we care about. So 75 moles is what the problem is asking for. That would be 3 times the amount shown in your balanced equation. So if we triple the amount of oxygen, we have to triple the amount of CO2 that we would get. So we would end up with 48 moles of CO2, because if we triple the amount of oxygen, we're going to triple the amount of product that we get. All right, and last but not least, if you needed to produce 9 moles of water, so water is over here, how many moles of C8H18 would you need? So now we're comparing water and C8H18. The recipe tells us that for every 2 moles of C8H18, we would produce 18 moles of water. We only want to produce 9 moles of water, so we're going to cut our recipe in half. So instead of 2 moles of C8H18, this would only require 1 mole, because we want to cut the amount of product that we get in half. So when you read through the problem, it's really, really, really important that you look to see which two chemicals you're comparing for the mole ratio, because each problem will only compare 2 substances. All right, so I believe you have these in your notes packet. So when you're using the mole ratio, you are starting with one specific element and you're ending with a different element. So you're comparing basically the amount of butter to the amount of sugar, or the amount of sugar to the amount of flour. Like you're comparing 2 different substances. All right, so we want to calculate the moles of NH3. So we are comparing the ratio of NH3 produced from 15 moles of H2. So in your balanced equation, we're only comparing these two substances. We don't really care about N2. You still need it in the reaction, but we're not going to use the coefficient for any of the calculations. So the setup is the same. We want to know how many moles of NH3 we need. And you always start with the number given in the problem. And make sure you label everything. So now we're going to label even the chemical that we need so we can make sure all the units cancel out appropriately. So you're going to set up the problem the same. Whatever unit you start with on top gets transferred to the bottom of the next step. And now this is our mole ratio step. So the mole ratio from your balanced equation is are going to be the elements, are going to be the numbers that we use for this step. So moles of H2, the problem tells us is 3, or my balanced equation tells us is 3. We want to know moles of NH3, so that's going to go on top. The balanced equation tells us that for every 3 moles of H2, I'm going to produce 2 moles of NH3. So that would be your mole ratio that you would add to the second step of the problem. Moles of H2 cancels out with moles of H2. You're left with moles of NH3. So then you do the same thing. You multiply the numbers across the top, divide by the numbers along the bottom. So 15.0 times 2 is 30.0. Divided by 3 would be 10.0 moles of NH3. So if you started with 15 moles of hydrogen, you would produce 10 moles of NH3. All right, let's look at question 2. We want to know how many moles of N2. Here, I'm going to erase that information from number 1. So we want to know how many moles of N2. So now we're comparing N2 are needed to react with 3.75 moles of H2. So now I'm only comparing N2 and H2. So that's what I'll use for my mole ratio. So again, we want to know question mark moles of N2. We start with the number given in the problem. So we're going to start with 3.75 moles of H2. Whatever unit you start with on the top gets transferred to the bottom of the next step. And then this is your mole ratio that you would find from the balanced equation. So this is going to be from, your coefficients in the balanced equation. Sorry, my writing is a little messy. So moles of H2, we know that 3 moles of H2. We want to end up with how many moles of N2? So moles of N2 is going to go on top. From the balanced equation, we know that 1 mole of N2 reacts with 3 moles of H2. So moles of H2 cancels out. You're left with moles of N2, which is what you want. So 3.75 times 1 divided by 3 would give you a final answer of 1.25 moles of N2. So this is how you would use the mole ratio. And you use the mole ratio when you switch from one chemical to another.